Okay, so we've talked about our physical chemical properties. We've talked about how to describe what matter is. Now I want to see the changing of matter. So changing of matter happen in two ways: physical change, chemical change. So a physical change is when a substance changes without altering its identity. So for instance, in your lab last week when you did the Twizzlers, when you cut them into pieces, it was a physical change. It was no all that happened is that you made smaller pieces of the substance. You did not change it in any other way. You didn't melt it down. You didn't try to dissolve it. All you did was do that. Now, if when you ate it, that was a chemical change because it broke down to what it was made of. So if you break something, split it, boil, freeze, melt, dissolve it, depending on the reaction, crushing it, cutting it, bending it, evaporating. These are all different physical changes. So it does not change the chemical formula of the object. So physical changes can be used to separate mixtures. So we have filtration. So you've heard of filtered water. You're filtering out the substances you don't want to drink. Same thing goes with your air filter in your house. It tries to keep out dust particles from getting around your house. So it's separation of solid and liquid, or separation of gas, solid and gas, or any of those ways to filter. Distillation is different. So this is how you get our distilled water. So separating a solution based on different boiling points. So you boil, you have extreme heat. So you boil all of the water and different substances off, and then you condense what is left. So this is actually how they make rubbing alcohol. So rubbing alcohol, you take the substance, you distill it, you burn off the rubbing alcohol, and it condenses back down into the bottle. So distilling drinking water, your warm water comes out, your water vapor comes down, boiling temperature to seawater. So you boil it, come through, and you have your drinking water. So you get some things that you do not need to stay in your boiling water. So that would take out all of your uh, take out all of in this particular case, take out all of your sediment and your salt. So you can also use chromatography. This is another way to separate mixtures. So this based them on the difference of their solubility. Remember, solubility is the ability to dissolve. So when you take a mixture and you use chromatography, it will gradually show out, and you can see what was in that mixture. So for instance, here you're dissolving different things, and as it dissolves, it will go through the distillation paper or the chromatography paper. And then crystallization is freezing. Different things have different freezing points. So it's just like distillation, except you are freezing water when another liquid may not freeze, or you're freezing oil when water won't freeze, things like that. All right, so the other thing is chemical change. So change the entire composition of the substance, the entire chemical formula of the substance. It changes everything dealing with your the identity of the substance. That's the word I was looking for. So when there is a chemical change, you will see these particular things. So if there's a production of light or heat or sound or a new odor, or a gas comes in, or a precipitate, which is a solid, if any of these things happen, a chemical change occurs. Remember, a chemical change can happen to any object, but it does not have to be a release of heat. You can also have an absorption of heat. So that means a container gets cold. So if a thing chills, then it could be instantly it can't be a chemical reaction. Remember, chemical change, chemical reaction are synonymous. They mean the same thing. So do your self-test, and I will have a spot where you can do this on your Edpuzzle. And good luck. I think that is it for. Wait. I got one more thing. So let's see. I'll pause it real quick over here. I apologize. So, chemical reaction means that we have a combination of two things. So, for instance, when we have iron and oxygen, they will become iron oxide. So that means you have a tendency for something to rust. That means everything that's on Mars' surface is the reaction. So the reactants are the things at first, then your products are the middle. So this should be an arrow. All right. So like I said, anything before the arrow is a reactant or your starting material. Your final material is your product. So everything after the arrow. Arrow means to yield or to produce. So if you hear those two words, or sometimes I'll say equals, that means that a reaction is happening. The arrow represents that. So in this, remember, law of conservation of mass. Mass cannot be created nor destroyed. So in a reaction, the mass of the products must equal the mass of the reactants. So whether that means that you lose a gas and that your final solid is going to be less mass, that means the gas is going to be created and it will be a part of that mass. But mass cannot be created nor destroyed. So you know if you are missing mass in your product, you have lost some sort of gas in your products as well. So energy is needed for both physical and chemical changes. Remember, freezing or melting causes a physical change, but you still need energy for that. Same thing with a chemical change. You can't just put things together. So what if there is some sort of release of a gas? Most of the time that means that there is some sort of energy being produced through that. So energy is doing the work for the reactions. So remember, release of heat or absorption of heat. Absorption of heat means that there is a endothermic reaction, endo meaning inside. So there's more of a thermic, so all the heat is coming into the reaction. Exothermic means that it feels hot. So you see fire or you feel heat coming off the substance. That is a exothermic reaction. And that's it. So good luck. I will have an assignment for you, and we'll talk later.